Hello guys, you're welcome back to my channel, Fun with Physics. In this lesson, we are going to consider the conservation of energy. First, we need to know what energy means. Energy is the ability to do work. We have different forms or different types of energy. Now, in the image here, we can see a wheel being spun by a flowing water. What type of energy has been transferred to the wheel by the flowing water? The list of the type of energy is endless. We have sound energy, we have light, we have thermal, nuclear, gravitational, electrical, mechanical, chemical, geothermal, elastic, and so on. These energy can be converted from one form to the other. Okay, for instance, light energy can be converted to chemical energy through a process of photosynthesis. Electrical energy can be converted to thermal energy, and then chemical energy from the food we eat and ice cream can be converted to mechanical energy, and so on. All these forms of energy are broadly categorized under two major categories. We have the kinetic or movement energy type, and then the potential or stored energy type. Usually the stored energy is due to relative position of two objects apart from each other, which I will discuss shortly. The kinetic energy category, like I said earlier, are due to movement of particles, right? Like we have here a lot of, in this case, we have a wind vane. When it moves, it transfers mechanical energy to electrical energy, right? Something has to move here. In electrical energy, the electrons has to flow. Thermal energy, sound energy, the particles have to kind of vibrate. Okay, now this form of energy here are classified under kinetic energy, while the potential energy are usually the stored type. Like I said earlier, potential energy is due to a relative shift in position between two particles. For instance, when a spring is stretched, the head and the tail of the spring is stretched, there's a shift between the two parts of the spring. This helps the spring to store what is called elastic energy. Also, when you move something above the ground, you're shifting it, you're moving it above, relative to the ground, above the ground. So in this way, it's able to store some form of energy. Particles in atom can also store this kind of energy when you move them apart slightly. All of these mentioned energy can be conserved. Can you figure out what it means to conserve energy? Now, if you look at the diagram by my right hand side here, you will notice a pendulum bulb oscillating. Now, notice that when one moves apart and strikes the rest, only one tends to move backward. Okay, this is an idea of energy conservation. What do you think it means to conserve energy? Energy cannot be created or destroyed, but can be transferred or transformed from one form to another. This is a principle of conservation of energy. Like chemical energy converting entirely to mechanical energy. chemical energy converting to light energy, or chemical energy converting to mechanical, or electrical energy converting to light. So the whole of the energy, starting energy, is converted to useful output energy. Now, not all of the energy is converted. Sometimes some are wasted or dissipated to the environment in form of heat or sound. For instance, the biker here wasted a lot of chemical energy in his body in form of heat energy, which is absorbed by the environment. You can see that the heat is dissipated to the environment. Okay, so a lot of energy here is wasted or lost, rather wasted instead of lost, to the environment. Okay, let's use the light bulb as a case study to know what happened when you turn on a light bulb. The light bulb emits light and also gets warmer. So we can say two forms of energy is transferred or transformed in this case. First, the light energy and the wasted heat energy. Okay, so if the input energy is, let's say, 100 joule electrical energy, 20 joule is transferred to light energy, and then the remaining, which is 80 joule, is wasted as heat energy. Okay, so the wasted one can be said to be given off or dissipated to the environment. Can you tell how a car wastes some of its chemical energy from fuel used to drive the moving parts of the car? How about the trolley? In what form is the energy wasted and by what process? Okay, let's start with the trolley. The process of wasting energy here is due to friction. There's a friction between the moving parts, that's the wheel and the track. So because of friction, most of the energy is wasted in form of heat and sound. For the car, the same thing applies. There are lots of moving parts in the engine which rub against each other, producing a lot of heat and sound. Okay, so in this way, most of the energy, the chemical energy from the fuel, is wasted as heat and sound. Energy transfer can be expressed sometimes using a diagram which we call the energy transfer diagram. We have three simple cases here. For the first case, which is a light bulb, battery powered. If the battery supplies chemical energy and transfers the chemical energy to electrical energy, we tend to get two outputs, that is light and heat or thermal energy. Okay, so we can draw the diagram this way. Chemical energy produces electrical energy, and this gives two output energy, the light and then the thermal energy. Okay, while one is useful, the straight one, the other one here is wasted or dissipated to the environment. Now for our TV set, it transfers electrical energy to three forms of energy that are useful, two forms that are useful and one wasted. The sound and the light are useful to us, and then the heat is not useful, so it's wasted. Can you draw the energy transfer diagram of a battery powered radio? When we have more useful energy than the wasted one in any system, we can say that the system is efficient. Okay, like in this case here, we have less useful, this is a useful, the light, than the heat. The heat will have more wasted here, right? 90 joule of energy is wasted. So this is not efficient. Energy efficiency is the use of less energy to perform the same task or to produce the same result. Now, in the diagram here, we have two guys that are assumed to have the same input energy from the food they eat. Okay, they use it to push these two objects, but one is more efficient than the other one. This one, of course, is more efficient because he's using a very little output energy to push this. Okay, while this one uses a whole lot of output energy to push the object. Okay, now notice here that friction is greatly reduced than this. Now we can see that this guy here is more efficient than the other one. Which of the lamp wastes more energy? Which one is efficient and why? So we have two lamps here. We have a filament lamp, we have LED. The one that wastes more energy, of course, is the filament lamp. And the one that wastes less energy is the LED. Okay, so we can say this LED is more efficient because the output energy is about 75 joule, which is bigger than the wasted one. We can find the efficiency of any system using the formula efficiency, the useful energy output over total energy input. Or we can even find the percentage efficiency using the useful energy output over total energy input times 100%. So it means we can plug in these values here in the formula and then get our efficiency. For instance, our 10 here can be plugged into the useful energy. Then our 100 here can be plugged into the output energy. Okay, so 10 over 100, that gives us the efficiency. We can express it in percentage by multiplying by 100. Okay, so when we do that, it will show us that this one is 75% efficient and this one is just 10% efficient. In summary, is energy conservation in the figure below? Is energy conserved in the figure below? Explain why you think the energy is conserved in each case. So in the first case here, we have a trolley rolling down the hill. Now notice that as the trolley rolls down, the potential energy, which is represented by the PE, the blue color, seems to drop, and then the kinetic energy represented by the red color seems to rise. Okay, so at the ground level, notice that all the potential energy has been converted to kinetic energy, so we can say it's conserved. So number one is conserved because all of the potential energy of the object, that position, is converted to the kinetic energy at the ground level. For the second figure, we see some bikers pedaling. The chemical energy in their body transfers to to mechanical energy to pedal the wheel, and as they pedal, they sweat it out. That means some of the energy is wasted in form of heat, and even sound energy is given off when they pedal. Okay, so energy is also conserved in this case. In this case, we see the pendulum oscillating. When it strikes this, only one move out. So it's conserved. Energy is conserved because the input equals to the output. What are the energy transformation taking place here? And the second one, in what form is the energy wasted? So the first one, the energy transformation taking place is electrical to light energy. Some form of heat is given out or dissipated to the environment by the bulb. So the wasted energy is, of course, thermal energy. Now the second one here, we have a roller coaster. You have to move up and down, up and down, up and down. So the energy transformation taking place is from potential or gravitational potential energy at the height to kinetic energy below the height when it roll down. Okay, so this energy is transferred from one potential gravitational potential to the other kinetic as it keeps rolling. A lot of energy is wasted in the process as heat and sound. Okay guys, I hope you understand the video. If you're sure you understand, please leave a thumb up and like this video for more videos like this. Thank you.